Hi folks, this is our tutorial on scientific notation and SigFigs. You have access to this PowerPoint online, and you can follow along on this video as well. So scientific notation is important in communicating numbers. It also tells how many significant figures you have very clearly. If you look at this number, 6.87, there are 3 numerals in that number and 3 significant figures. That one's really easy. I hope you've already read through the significant figure section of the textbook, and probably want to read it again after watching this video. We'll get lots of practice in class as well. The key point here, scientific notation always has the largest place value in the ones place, the 6, right, in the ones place. You don't have a tens place in scientific notation. You always just have a ones place, and then every digit after that comes in after the decimal, and then you use a times 10 to the sum exponent to communicate the magnitude of the number. So every digit after the decimal point is significant. This has 3 sig figs, 6.87. In scientific notation, it just is what it is for 6.87. Here's the number 209. So think about, how do I put that in scientific notation, and how many sig figs does it have? So remember, we're going to just have something in the ones place, and then immediately followed by a decimal point. Any zeros that come between 2 non-zero integers, for example, the 0 and 209, are always going to be significant. It has 3 sig figs, 2, 0, 9, all 3 are significant. When we put it into scientific notation, we have a ones place, a decimal point, and then all the other numbers. Obviously, we've moved our decimal point 2 places, 1, 2. So we're going to multiply by 10 to the 2 to communicate that this number in scientific notation is actually 209. All right, here's another example, 0.350. So this is a decimal with a 0 in the ones place. When we put it into scientific notation, we're going to move that 3 over to the ones place. Zeros that come at the end of a number after a decimal point in scientific notation are significant. So once we move that decimal point and put it into scientific notation, that 0 needs to remain because it's after the decimal point, so it is significant. The 0 before the decimal point, when it's not in scientific notation, disappears when you put it into scientific notation, and so that 0 is not significant. So we have 3 sig figs, the 3, the 5, and the 0 at the end. When we put it into scientific notation, then that 0 at the end remains because it communicates the precision of the instruments that we used to take that measurement. But the 0 that was in the front when that was a decimal is not significant. Since we had to move our decimal point 1 place to the right to put it into scientific notation, then we need to use this times 10 to the negative 1 to communicate that it's really 0.350. Always put this 0 in front of a decimal when you're not using scientific notation, because my eyes are old and I can't always see your tiny decimal points. All right. Let's see, the number 200. So in this case, we have to figure out how many significant figures we have in this number. This can be a little confusing. So remember that when we have zeros at the end of a number before a decimal point, they are not significant. So if you simply write the number 200 by itself, how many sig figs does it have? Just 1. Just the 2 is significant. So this number could mean anything from 183 to 249, right? Anything that would round to 200 could be communicated by that number, because their zeros are not significant unless you take action to make them significant. You have to consider the precision of the tools you're using. If I were to put 200 into scientific notation, it would be 2 times 10 to the 2, because I moved my decimal 1, 2 places. Now if I write that number differently, and this is Okay, so as I was saying, it's very important in chemistry because we'll use glassware that has varying amount of precision. And so 200 with no decimal point or indication of significance is very different than 200 with these. So how many sig figs does this number have? Remember, this only had one sig fig, just the two. These zeros are not significant. This actually has 4 because these zeros are all significant. These come between a numeral and a decimal point, and this one after the decimal point. So these 3 zeros and the 2 are all significant in this number. To write it in scientific notation, we actually keep all four significant figures. Since we have to move our decimal 1, 2 places to the left, we have times 10 to the 2 to communicate that this is 200.0. The only way to indicate that this number needs to have 3 sig figs is to use scientific notation. If you actually write 200.0 milliliters, for example, on your lab sheet, that is still correct. But if you just write 200 and your glassware actually had precision to the 10th place when you made that measurement, this would not be correct. This would be fine. Scientific notation is always welcome. But this would still be fine as well. Now, if I wanted to have 3, this is 3 sig figs, not 4, then I could put a decimal point and have 200 with just a decimal point and nothing after it, and that would show that these are remaining significant. But scientific notation is the only way to really indicate that this would be 3 sig figs. 2.00 times 10 to the 2 communicates 200 with 3 sig figs the very best way. Okay, there we go. More practice. So put this into scientific notation and tell how many sig figs you've got. Right, so you're going to make the 2 be in the ones place, have a decimal after it, and then all the digits. So how many sig figs? It's 4. And scientific notation times 10 to the what? Okay, so 2.565 times 10 to the 3 communicates 2,565 in scientific notation. All right, now this number, 0.00821, how many sig figs does that have? Are these zeros significant? So they're not, because they'll go away when we put this in scientific notation. So this has 1, 2, 3, only 3 sig figs. The zeros that come before non-zero integers are not significant, they're just placeholders. 3 sig figs, and you can see those zeros did go away when we put it into scientific notation. So our decimal point moved 1, 2, 3 places to the right, so we have 10 to the negative 3 as our scientific notation. Okay, here we go. So why do we bother with scientific notation and significant figures? Well, sig figs come from the precision of your tools. My kitchen scale measures just to 1 gram. It only ends. It says this weighs 10 grams or 11 grams or 12 grams. My chemistry scale could say this weighs 11.13 grams. So it gives me much more precision. And our data reflects the sensitivity of our tools. So if you are reading a graduated cylinder or a ruler or any tool in the lab, you can measure 1 place value between the lines. Even if you're reading a graph in the book, you measure your significant figures 1 place value between the lines. So when you're adding and subtracting, and then you have to consider how to keep significant figures, that can be a challenge. And I'm probably running out of time and might need to start a new video. Yep, let's do that. Okay, so let's talk about adding and subtracting with significant figures. When you're adding and subtracting, the key point is place value matters. Is the end of significance in the ones place, in the tens place, in the hundreds place, or maybe even the thousandths place. But number of significant figures in each data point doesn't matter, only place value. So let's add up 2,565 plus 362. So what is the place of least significance? Where does significance end in these two numbers? They both have significance in the ones place, which I've tried to circle here kind of badly. And so since they both have significance in the ones place, we will be allowed to keep a ones place. So when we add them up, we can keep the ones place. So we can keep all the digits, 2,927, for significant figures in that answer. Both add-ons are significant to the ones place, so you just report your answer to the ones place. All right, so let's make it a little harder. So we have the number 2,500. Now these two zeros are not significant because they're not in scientific notation. There's no decimal point here to indicate significance. So the place of least significance is the hundreds place. The 5 here is in the hundreds place. And then if we add 362, well, that's actually significant all the way to the ones place. But when we compare them, the worst one is this 2,500, significant only to the hundreds place. Once we add them up, 2,862, we're going to have to round because we can only keep significance to the hundreds place because of this number that is only significant in the hundreds place. This 6 will make the 8 round up, and so our final answer will be 2,900. So in math, your answer is 2,862. In chemistry, because of sig figs, the answer to this math problem would be 2,900. The place of least significance is in the hundreds place, so you have to round the whole answer to the hundreds place. You will be very frustrated at times during the year because of that. That's why it's also important to use excellent glassware and tools and use them properly so that you can keep as many significant places as you can. All right, here's where they'll trick you. The number 10, how many sig figs do we have? The number 6, how many sig figs do we have? Well, it doesn't matter, place of least significance. The 10 is significant in the tens place. This 0 is not significant. The 6 in the ones place. When we add them up, we get 16, but we have to round because we can only keep to the tens place. That's 16. The 6 would make the 1 round up to a 2. So 10 plus 16 is 20 because we are only allowed to keep the worst, the place of significance here. So we have to keep only a tens place. So yes, 10 plus 6 is 20. Okay, so we have to round to the worst place value, basically, in sig figs when you're adding and subtracting. Multiplying and dividing with significant figures is completely different than adding and subtracting. Key point. You just count the sig figs in each number of the problem, take the worst one, and round to that number of sig figs. So here we go. If we're going to do miles per hour, 5.000, how many sig figs is that? Hopefully you said 4. 2.5, how many sig figs is that? Hopefully you said 2. So I'll just type into my calculator 5 divided by 2.5, and then I'll say this has 4, this has 2. 2 is the worst, so I can keep 2 sig figs in my answer. All right, 5.000 has 4, 2.5 has 2. I can divide 5 by 2.5, I get the answer 2. I get to keep 2 sig figs because I'm limited by this, so I'll write 2.0 on my paper to show 2 sig figs. And always keep your units, miles per hour. So 2.0 miles per hour with 2 sig figs is the correct answer. All right, so now we have 10. How many sig figs? It's just 1. Times 6, how many sig figs? That's also 1. So instead of adding, we're just multiplying. So we count sig figs. 1 sig fig here, 1 sig fig here. 10 times 6 is 60, right? This has 1 sig fig, so that's correct, right? So I can keep my answer as 60 because that has 1 sig fig. But remember, the ones place is not significant. Okay, so we did this problem in the last video. One last problem we have. Instead of 10, 1.0 times 10 to the 1, that means 10, right? But with 2 sig figs instead of 1. And then 6.0, that means 6 with 2 sig figs. So we have 10 with 2 sig figs times 6 with 2 sig figs. How many sig figs can we keep in the answer when we multiply? Well, if we have 2 here and 2 here, we get to keep 2 in the answer. So we have an answer of 60 again, but to express 60 with 2 sig figs, we write it in scientific notation. 6.0 times 10 to the 1 means 60. So that is a quick tutorial on how to figure out how many sig figs a number has, write it in scientific notation, add and subtract with sig figs, and multiply with sig figs. So we'll get lots of practice in class, lots of practice in your problems, and I'll be nice about not taking off for sig figs on the first test, and then we'll kind of ease into maybe losing an eighth of a point on a problem if you don't do sig figs correctly. Remember, you get to correct your tests for half back. So if this is hard for you, it's not going to be crushing to your grade, and you will have time to learn how to add and subtract and multiply and divide with sig figs so that you'll be successful. So don't worry, this is all new to you, but soon it will be old hat and you'll be used to it. And remember, it just expresses the precision of your instruments, which is super important. Sig figs have caused many failures to complete engineering projects and many mistakes in measuring in chemistry because people didn't take them seriously. So they're very important. And though they might make us frustrated at some points in the year, they will make sure that your projects throughout your life are successful. So hopefully you will find them to be a fun puzzle instead of a pain, because they're just like one little extra puzzle piece to each problem. So